Everyone, and welcome to our video on finding a fourth derivative or a fourth order derivative. Okay, so with this, we see the little 4 up there. So that means find the fourth derivative. And what we really need is to first find the first derivative and then find the second derivative and then the third and then the fourth. Okay, so that's going to take some time. So here's our first derivative. So all it is really a patience game and make sure you're simplifying okay. Okay, so our first derivative, we see that we have a quotient. So we have a high and low function. And so I'm going to write our derivative notation as f prime of x equals our low d high minus our high d low over low low. Okay, so I'm just using my formula. So whenever it's a quotient, use the formula for the quotient rule. And then now we'll start to plug it in. So f prime of x, my low is x plus 2. My derivative of the high would be 1. And then minus my high, which is x. The derivative of the low is also 1. And then over low getting squared. So x plus 2 getting squared. And then let's simplify. So let's put this over here to be safe with room. So I would distribute the 1. And then the negative and this multiplies. So we would have x plus 2 minus x over x plus 2 squared. Okay, so this is nice because x minus x is 0. So this is a better problem than it might have looked like at first. So it's 2 over x plus 2 squared. However, this we can change since there's no variable in the numerator. No variable in numerator. Let's rewrite this expression. Let's rewrite this using a negative power. So then we can make this a non-quotient rule problem. So let's rewrite using a negative power. And if we do that, so let's see it. So f prime of x would be 2. And then x plus 2 to the negative 2. And then now it's a little bit easier problem, I would say. Now this is an easier chain rule problem. So the chain rule can be nasty, but I think in this scenario, it's easier. Okay, so now let's break it down. So I have this is our first derivative, and then now step 2, let's get our second derivative. All right, so we have f double prime of x is, well, this 2 is just hanging out. Our chain rule tells us to take this negative 2 and multiply the front. And then we'll have x plus 2 to the negative 2 left over. And then the chain rule tells you then multiply, oops, not negative 2, sorry, I need to minus 1. Okay, so the chain rule, let me show it in blue. So I needed to put that in the front, and then we'll need to minus 1 from that power, so that should be negative 3. And then we need to times it by the derivative of the inside parentheses, so times 1. So that's the derivative of the x plus 2 right there. Okay, so I'm doing the chain rule without actually using a u substitution. I think because it's so nice in there, I think we could just break it down in words just like this. Okay, and then that way, now I can simplify. Our f double prime of x is 2 times negative 2 is negative 4. And then we have x plus 2 to the negative 3 times 1 is still just like that. All right, so that's our second derivatives. Okay, so the first step looked like the worst, and now let's keep cruising. Okay, so our third derivative would be f triple prime x. Again, the negative 4, the front coefficient would just be hanging out. And let me put all of this in blue. So the negative 3 would come to the front, and then I'd have x plus 2. Minus 1 from that power would be negative 4 times the derivative of that x plus 2, which is 1. So I'm showing it in case it was a little bit more complicated. We would want to make sure we still do that. So if in case it's anything besides 1. All right, and then now let's simplify. So our third order derivative is, well, negative 4 times negative 3 times 1 is positive 12. And then we have x plus 2 to the negative 4. Okay, so there's our third. And then now finally we could get our fourth. The fourth derivative. So we usually want to do 4 primes at this point. We do 4 in the parentheses. And then the 12 is just hanging out. And then doing the derivative of this portion, negative 4 comes to the front. And then we have x plus 2 minus 1 from the power would be negative 5 times the derivative of x plus 2 times the derivative of that inside would be 1. And then now it looks like we are very close to our final answer. Our fourth derivative, 12 times negative 4 times positive 1 is negative 48. And then we have x plus 2 to the negative 5. And then if they said, all right, no negative powers, well, let's change it. So let's get our final answer. So negative 48, I'm going to write in the numerator. X plus 2 to the 5th is going down in the denominator. So I'm using the rule for negative powers. And there it is. That's our fourth order derivative. Okay, so I thought it was going to be a little worse than what we started with because of the quotient rule. But if we use the chain rule to change it, we can make this a little easier on ourselves. You could have used the quotient rule the whole time. It would have worked the same way, but I think it would have added steps. All right, so that's finding a fourth order derivative. So either way, whatever derivative they want you to find, higher order wise, all it is just find the first, second, third, fourth, so forth. So be ready if that's numbers big, just be ready to do a lot of derivatives. All right, but that's all. So thanks for watching. If you have questions, let me know, and I'll see you again next time.